Good morning, everyone. I am Dr. Dhananjay Palke, Professor and Head Department of Chemistry and Analytical Chemistry. In this video, we will study heterocyclic compound. Heterocyclic compounds are cyclic compound in which one or more heteroatom like nitrogen, oxygen, sulfur, phosphorus, silicon, etc. are present as a member of cyclic ring are known as heterocyclic compound. Heterocyclic compounds are classified 5-membered ring heterocyclic compound, 6-membered ring heterocyclic compound, and condensed ring heterocyclic compound. In last video, we study the reactions of 5-membered ring heterocyclic compound, and now we will see preparation and reaction of 6-membered ring heterocyclic compounds. 6-membered ring heterocyclic compounds, example pyridine. Here 5 carbon atom and 1 nitrogen atom are present in cyclic structure, and its IUPAC name is azine, and numbering always start from heteroatom. Therefore, either 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. That is pyridine or azine. We will see preparation of pyridine. There are two methods of preparation of pyridine. One from acetylene, in which pyridine is prepared by passing the mixture of acetylene and hydrogen cyanide through red hot tube, undergo cyclization to form 6-membered ring, that is pyridine. Here hydrogen cyanide, hydrogen, carbon and nitrogen. Nitrogen is more electronegative than carbon. Therefore, the pi bond is break and nitrogen acquire negative charge, carbon acquire positive charge, and these charges or dipolar ions attack on one molecule of acetylene, or nitrogen attack on electron deficient carbon atom of acetylene, and this pi bond is also break, positive carbon, negative carbon, nitrogen attack on carbon, this carbon become negative, and this negatively charged carbon attack on second molecule of acetylene. Here again negative carbon, positive carbon, there is bond formation, this pi bond is broken, and this negatively charged carbon attack on triply bonded carbon atom of cyanide. That is cyclization in between these two carbon atom, and carbon and nitrogen. Here we shown the new bond formed, that is CC bond, this CC bond and this CN bond, shown by red ink, and one bond broken out of 3. One broken carbon-carbon double bond. Here one broken carbon-carbon double bond, one bond broken carbon-nitrogen double bond, and formation of pyridine. Second method, pyridine can also be prepared from pentamethylene diamine hydrochloride. By heating pentamethylene diamine hydrochloride, undergo cyclization again with elimination of ammonium chloride and hydrochloric acid to form piperidine, that is one molecule of ammonium chloride, one molecule of hydrochloric acid remove, and bond formation between this nitrogen and carbon atom, that is 6-membered ring. And this piperidine by heating with concentrated sulfuric acid undergo dehydrogenation. One hydrogen from nitrogen and this carbon atom, formation of carbon nitrogen double bond, hydrogen atom from these two carbon atom, formation of carbon carbon double bond, and elimination of hydrogen molecule from these two carbon atom, again formation of carbon carbon double bond, that is pyridine. In this way, pyridine can be prepared from acetylene or another method from pentamethylene diamine hydrochloride. Reactivity of pyridine. We seen that 5-membered ring heterocyclic compounds are reactive toward electrophilic substitution reaction, but do not undergo nucleophilic substitution reaction. In case of pyridine, pyridine is less reactive towards electrophilic substitution reaction because nitrogen is more electronegative and it decreases the electron density in pyridine ring. And as electron density in the ring decreases, then attack of electrophile becomes difficult. And another reason, electrophile can attack on nitrogen atom of pyridine instead of ring carbon atom. Therefore, pyridine is less reactive toward electrophilic substitution reaction. Therefore, pyridine undergo electrophilic substitution reaction under drastic condition by means of high temperature and high pressure, and undergo electrophilic substitution reaction at carbon number 3. And also, pyridine undergo nucleophilic substitution reaction, oxidation and reduction reaction. We see one by one. Electrophilic substitution reaction, that is substitution reaction in which electrophile attack or reaction initiated by attack of electrophile, or also say that electrophilic substitution reactions are those reactions in which weaker electrophile is displaced by stronger electrophile to form substitution product, are known as electrophilic substitution reaction. Example, nitration. Nitration is electrophilic substitution reaction in which hydrogen atom of pyridine ring at carbon number 3 is replaced by electrophile nitro group. When pyridine react with nitrating mixture, that is concentrated sulfuric acid and concentrated nitric acid, or sometime in place of nitric acid potassium nitrate can also be used, or the mixture of concentrated sulfuric acid and potassium nitrate also undergo electrophilic substitution reaction nitration to form 3-nitropyridine. Pyridine on nitration undergo electrophilic substitution reaction to form 3-nitropyridine. Or nitration can also be, we can say that, introduction of nitro group. Nitration is introduction of nitro group, or nitration is the reaction in which hydrogen atom is replaced by nitro group, is known as nitration. Another reaction, sulfonation. Sulfonation is also electrophilic substitution reaction in which hydrogen atom at carbon number 3 is replaced by SO3H group, that is sulfonic acid group, or introduction of sulfonic acid group in the aromatic ring is known as sulfonation. Pyridine undergo sulfonation by heating with fuming sulfuric acid or oleum in presence of mercuric sulfate to form pyridine 3-sulfonic acid. Pyridine on sulfonation produces pyridine 3-sulfonic acid. Another electrophilic substitution reaction is halogenation, that is chlorination, bromination or iodination. Pyridine undergo bromination at about 300 degrees Celsius temperature in presence of charcoal catalyst. And pyridine is more reactive toward halogenation. Therefore, it gives a mixture of 3-bromopyridine and 3,5-dibromopyridine. That is, pyridine react with bromine in presence of charcoal catalyst at about 300 degrees Celsius temperature, formation of mixture of 3-bromopyridine and 3,5-dibromopyridine. These are electrophilic substitution reactions of pyridine. And pyridine undergo nucleophilic substitution reaction also. Nucleophilic substitution reactions are the substitution reaction initiated by attack of nucleophile. Or we can say that nucleophilic substitution reactions are those substitution reaction in which weaker nucleophile is displaced by stronger nucleophile. Example, Kiki-Babin reaction. Kiki-Babin, CHI-CHI-BA-BIN. Kiki-Babin reaction. It is name reaction in which pyridine heated with soda-amine. Pyridine heated with soda-amine in presence of liquid ammonia at about 100 degrees Celsius temperature undergo nucleophilic substitution reaction at carbon number 2 because nitrogen or due to presence of nitrogen electron density decreases mainly at carbon number 2, 4 and 6. That is carbon both 2 or 2 and 6. Mechanism of Kiki-Babin reaction or nucleophilic substitution reaction. Here, step first, formation of nucleophile. Nucleophile, here NH2 minus or amine anion. Soda amine in presence of liquid ammonia dissociated to sodium cation and NH2 anion. And NH2 anion acts as nucleophile. Second step, attack of nucleophile. Attack of nucleophile. NH2 minus anion attack on electron deficient carbon atom of pyridine, that is carbon number 2. It is electron deficient and it is electron rich, or pi bond is break in such a way that here positive charge and here negative charge, or electron transfer from this carbon atom to this carbon atom. This carbon become positive, this carbon become negative, and nucleophile attack on electron deficient or positively charged carbon atom to form carbanion. And this carbanion ion is stabilizes by resonance. Here negative charge on this carbon atom, hydrogen initial, and in nucleophile NH2 is attacked, and this bond is broken, negatively charged carbon atom. Here again the pi bond between these two carbon atom is break in such a way that negative charge on this carbon atom, positive charge on this carbon atom, and the positive charged carbon and this negatively charged carbon, there is formation of pi bond, and here negative new bond formed, and this is another resonating structure. Again this anion is stabilizes, this bond is break, and here positive charge, here negative charge, and the formation of another resonating anion or carbanion ion, or this carbanion stabilizes by resonance. Next step, removal of hydrogen atom from carbanion ion, that is as hydride anion, and hydride anion and sodium cation, formation of sodium hydride. By removal of hydrogen, this carbon become negatively charged, positively charged. This carbon become positively charged, and bond formation between negatively charged carbon atom and positively charged carbon atom to form 2-aminopyridine. Pyridine also undergo reaction with N-butyl lithium. It is also nucleophilic substitution reaction. N-butyl group is nucleophilic, lithium is electrophilic. Pyridine treated with N-butyl lithium in the presence of dry ether to give 2-N-butyl pyridine. Another nucleophilic substitution reaction with potassium hydroxide or sodium hydroxide. Pyridine react with potassium hydroxide at about 300 degrees Celsius temperature, undergo nucleophilic substitution reaction. Hydrogen atom is replaced by OH group, and formation of 2-hydroxypyridine are known as pyridol. And this pyridol, on rearrangement, hydrogen atom shifted to nitrogen and bond is shifted to carbon-oxygen double bond, that is pyridone. Next reaction, reduction reaction. Pyridine undergo catalytic hydrogenation, that is reaction of hydrogen atom, hydrogen molecule in the presence of nickel catalyst or sodium hydroxide and ethanol. That is pyridine hydrogenated in presence of nickel, or pyridine undergo reduction in presence of sodium hydroxide and ethanol, and 3 carbon-carbon double bond get hydrogenate. That is hydrogen molecule added across this CN bond, this CC bond and this CC bond, and formation of piperidine. Oxidation, that is addition of oxygen. Pyridine undergo oxidation in presence of peracetic acid, and oxygen atom added on nitrogen to form pyridine N oxide. Pyridine react with oxygen in presence of peracetic acid to form pyridine N oxide. And another reaction, basic character of pyridine. We know that pyridine is basic in nature, and basic nature or basicity, that is pyridine molecule is able to react with hydrogen atom of acid or donate electron pair to the another molecule. Here pyridine react with hydrochloric acid, undergo neutralization reaction to form pyridine hydrochloride, and also pyridine react with methyl iodide, similar reaction to form N-methyl pyridinium iodide. Thank you, sir.